All right, so now what we're going to do is we're going to do some more practice on linear versus exponential. So please make sure you send this to Notability because I'm going to ask you to pause the video, try it on your own, and then you can just check your answers. You can fast forward and just look at the at the end of the section. Okay, so number 1 says for each function, tell whether it's linear or exponential. State the initial value. So when x is 0, what is y? And then state the constant change. Okay, so go ahead and pause the video and try the first 4 on your own. Okay, so A, I need to know if it's linear or exponential. So if you look at here, this is in the form mx plus b. So this is going to be linear. So it says tell whether it's linear or exponential. So I'll do that in blue. And I'm going to go through and do all of them right now since I want to keep my blue pen here. The next one, y equals, this is a times b to the x. So this is exponential. The next one, it's in the form y equals mx plus b. It's linear. And this one right here, it's in the form a times b to the x, exponential. So one thing that I do want you to notice is that sometimes we have parentheses wrapped around the b term. Sometimes it's not, okay? But I want you to recognize both. That's why we're switching them up here. Okay, the next thing that it asks in these problems here, it says state the initial value. Okay, so let's go and state the initial value. So I'm going to put initial. And then I'm going to copy and paste that for each problem. Copy, paste, paste, paste. Okay, so I want the initial value. Okay, so remember, b is your initial value for a linear equation. B is 9. All right, looking at exponential function, a is your initial value. So a is 5. Initial value for this one is 4 because b, and then a is 3 here for this exponential function. All right, the last thing that they ask me for in this problem is state the constant change. So now I'm going to write constant change. I'm going to go ahead and copy and paste this. Okay, so constant change in a linear equation is your m value. So my m value here is 2. So I don't just want to put 2. Is it multiplying by 2, adding 2, subtracting 2? So the most common mistake people make is that they put multiplying by 2 because it's 2 times x. It's, remember, for a linear equation, it's always adding or subtracting a number. Constant change for this one. B is your constant change. So this is times 2 because exponential is multiplier. So make sure you're not just putting 2 for either of those. This one, adding 6. This one, multiplying by 8. Okay. 6, 8. There we go. Okay. Number 2 says consider the equation y equals 5x3 plus 5x. Is it linear or exponential? Complete the table and then come up with a story relating to the equation. Okay? So you're going to make up your own story when we get to that, but let's just make sure we're okay with filling in the table. So first off, I want to know, is it linear or is this exponential? This is in the form y equals mx plus b, so it is linear. Complete the table for the equation. So we're going to say when we plug in 0, what do we get? Or another thing is you just know that that's the initial amount. So 3, right? 5 times 0 is 0, plus 3 is 3. Or I can say, that's my initial amount. All right, plug in 1. I get 8. Plug in 2. I get 13. Plug in 3. I get 18. Now really, I don't have to plug in 2, plug in 3. I can say, my constant change is 5. So once I have this 3, I can say plus 5, plus 5, plus 5, right? That makes sense? All right, now I need to come up with a story relating to this equation. So go ahead, pause the video, and make up your own story. All right, I'm going to make up my own story. I'm going to say I need an initial amount to start with. So the initial amount's 3. So I'm going to come up with the person's name. Joe has, and then I have to say he has 3 of something. I'm going to say dollars, okay? Now I need to say that it's increasing by 5 constantly. So I need to make a situation about the 5 additional. So I'm going to say he gets $5 more every week, or I can say every time he gets an A, he gets $5. Some such stipulation that he's going to get $5, and then I want to say it on a blank basis. So I'm going to say every week his uncle gives him $5. So notice I have a time frame, right? Or I could have said every day or every month, every year. But I need a time frame to show that it's happening on a constant basis. And then I also need to show that there's increments changing. So plus 5, plus 5, plus 5. Okay, next one. Consider the equation y equals 3 times 5 to the x. Is this linear or exponential? This is in the form y equals a times b to the x, so this is an exponential equation. Complete the table. I need to plug in 0 for x. So what I'm doing here, I want you to think about this 2 ways. It's 3 times 5 to the 0 power. Okay, so first off, when I ask usually people to do this, they'll say this is 0, which it's not. Let's check that in our calculators. Let's see what we get. If you do 5 to the 0 power, your calculator is going to tell you that this is 1, which is correct. So this is really 3 times 1, which is 3. But remember, we could have figured that out because we know that A is our initial amount, and A is 3. Okay, now we're going to plug in 1. 5 to the first power times 3. That's 15. Next, we have 3 times 5 to the second power. So that's 25 times 3, which is 75. But once again, we don't have to continually do this. We can say, oh yes, there is a constant multiplier of 5. So times 5, and now I just need to do times 5. 75 times 5 is 375. So notice there's 2 ways of getting your table values. All right, go ahead and pause the video, come up with a story that has to do with this equation. Okay, so I need an initial amount of 3 again, and it needs to be changing by, this time, a constant multiplier of 5. So I need to start with 3 of something. It doesn't always have to be money. You can pick anything you want. I'm going to use myself as an example. I'm going to say, at the beginning of e-learning, Mrs. Dellen had 3 gray hairs. So there's my initial amount. Okay. Every month, because remember I want a time period here because that's changing every month. And now I want to say how it's changing. I need to say that it's 5 times more, right? Because exponential functions multiplication. So every month she gets 5 times more. So be creative with your stories. We love reading them. Okay, so now what we're going to do is we're going to go through and we are going to consider 2 functions and answer the questions on them, okay? At the end, I'm going to have you write another scenario. It says, consider the 2 functions f of x equals x squared plus 2 and g of x equals 2 times 3 to the x power. So the first one says, does f of x represent a linear or exponential function? So we're looking at f of x. That is a linear function. Next question is what is the constant change? So remember, this is in the form mx plus b, and m is your constant change. So don't just say 8. Remember, for a linear function, since it's a positive 8, it's changing by adding 8. The next one says, does g of x represent a linear or exponential function? So now we're looking at g of x. This is an exponential form because it's in the form y equals a times b to the x. What's my constant change? My constant change is b. So my constant change is times by 3. So what you have to be careful of here is that your constant change is b right here with an exponential function, and here it's called m and not b, right? So that could be a little confusing for people. Make a table for each function. So both of my x values are going to be 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. All right, so 0 is my initial amount, so I know that's 2 for my function f of x. Or I could plug in 0 and see that I get 2. And now I'm going to get the rest of my table by increasing by 8. So plus 10, plus 18, or not plus 18, plus 8 is 10, plus 8 is 18, plus 8 is 26, plus 8 is 34. Once again, I could have just plugged in 4 right here and said 8 times 4 is 32, plus 2 is 34. Always 2 ways of getting that table. All right, now I'm going to do the next one. If I plug in 0 for x, I get 2 for g of x. Or I can say, oh yeah, what's my initial amount? It's a, which is 2. Now to get each additional, I'm going to use my multiplier of 3. So times 3 is 6, times 3 is 18, times 3 is 54, times 3 is 162. Okay? Once again, remember, I could have said, all right, what's 2 times 3 to the 4th power? Put this in my calculator first, and then multiply it by 2. Either one is fine. All right, next, graph each function so that all the points in your table can be seen. All right, so my x-axis, I'm going to say that obviously that when I'm labeling this, my first tick mark, which is this tick mark, is 0, and you don't have to label it because it's always has to be 0. Then I'm going to do 1, 2, 3, 4. So I could either do 2 here, 3 here, 4 here, 5 here if I wanted to. 1, oh no, that doesn't make any sense. Let's do 1 here, 2 here, 3 here, 4 here, 5 here. I first put 1 here, and that was only this, and then I said this was 1 more, which doesn't make sense. That's why you can see that it doesn't make sense. So you can do it the way I just did it, or you can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It just has to be up to 4, right? Okay, so now I look and I say that I have to get up to 34. If I have to get up to 34, that means I can't go by 1s on my y-axis, right? So if I want to go up to 34, I have to say, okay, I want to go by 4s because that way I can go by 40s, go up to 40. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. Right, so now I'm definitely going to fit it on there. All right, now I'm going to graph the points. So 0 was 2, right there. 1 was 10, so like there. 2 is 18, so like there. 3 is 26, so right there. 4 is 34, so right there. And if I wanted to, I can put 5 on there, which would be nice. I have to add 8. So I was at 34, adding 8 is 42, so off my chart, which is okay. All right, so I'm going to leave it discrete for now. And I'm going to make up, after I'm done making up my story, I'll be like, okay, do I leave it as discrete or do I make it continuous? All right, let's graph my exponential function. I'm going to do 0 once again and then every other. So I'll do 1, 2, 3, 4, 5. Okay, once again, you can do 0 through 10. It's fine. All right, so I need to get up to, at the very least, 162 to get that 4 on there. So I have to ask myself, what can I go by? So I'm going to say I'm going to get up to 200, and I'm going to go by 20s. So I'm going to go 20, 40, 60, 80, 100. 120, 140, 160, 180, 200. And now I got 4 162 that'll be on there. Okay, so 0, 2, like, whoa, that's so close, right? 1, 6, like, not much of an increase there. 218, so we're starting to move up a little. 354, big jump there. 4, 162, huge jump there, right? Once again, I'm going to make my points so you can see them better, but I'm not going to connect them until I decide if my story connects. Okay, so let's think of a scenario for f of x. Go ahead and pause your video and try yourself. Okay, so I'm going to make up this situation. So I'm going to say, I'm going to do filling a swimming pool for my linear equation. So I'm going to say Bob is filling a pool. So it has to start with 2. So I'm going to say 2 gallons. And how could a pool possibly start with 2 gallons? I can say it's rainwater. So I can say it starts with 2 gallons of rainwater. Now I have to say what's happening. So it's changing by 8. So I'm going to say it fills at 8 gallons, and then I need like a time. So I'm going to say per minute. So it fills at 8 gallons per minute. And there's my scenario. Okay. Now, do I keep it as discrete or do I connect it? So the question is that if this is time, minutes, and this is gallons, this we know is 30 seconds. Can I have after 30 seconds, it has a certain amount of water in it? Absolutely, right? Because the water is continuously filling up. So I'm going to go ahead and connect it. I don't know how long it goes on for, so I'll put an arrow on the end. I don't know. It didn't give me an end. Okay, next one. I need something to do with my exponential function. So I need to start with an initial amount of 2, and then it needs to multiply by 3. Okay, so I'll say I have 2 Twitter followers, very popular. Every day, my number of followers triples. I could have said multiplies by 3, but like I know the word triples means multiplies by 3. So now I need to know, do I connect it? Can I have this right here? X, my input, is number of followers. Can I have half of a follower? Nope. So I'm going to leave it as discrete. Okay. No, X is not the number of followers. My bad. Y is the number of followers. Y is the number of followers. Bless you. Let's put that back over here. And then this was the number of, and I forgot what I said, days. So number of days. So can I have a half day? Absolutely. But this one is actually up for debate because I can say I don't know what the in-between is. I know at the end of every day it triples, but what about in the morning? Like, is it just like 1 and then I get like 2 more a few minutes later, right? So this one's up for debate. I'm going to say that we're going to leave it like this because at the end of every day, it's going to triple. Okay, there we go. All right, that was the practice for today. If you have any questions, please ask. But